ax squared plus bx plus c, where a cannot equal 0. A cannot equal 0. If it were to equal 0, then it would just be an ex plus c function, which would be linear. So it has to be a number that is not 0. Hello? Hi? Sure. Yep. Thank you. Bye. All right, a parabola is the shape that this makes. It's the graph of a quadratic function, and it's like that horseshoe shape. Now, in Algebra 1, you did graph these, but the only way that you learned to graph these was by creating a table of values and then plotting them. We will learn some different ways to graph them, but if you want to also jot down a little picture, parabola would look like that. It also can be downward facing. So if it's reflected about the x-axis. And a lot of the stuff that we learned about absolute value functions, like our shifting left, right, up, down, that's going to apply to quadratics too, the translations. The axis of symmetry, and there was one also for our absolute value functions, but the axis of symmetry is an imaginary line that divides the parabola into two mirror images of one another. Almost if you folded the paper, they would match up. So the axis of symmetry is the line that divides the parabola into two mirror images. And the reason that this is useful is that you can actually plot just 2 points, and then you can reflect them about the axis of symmetry, and that way you don't have to actually find other points, because we know that it will be symmetric. The axis of symmetry will always be a vertical line. We should probably jot that down. So the equation for the axis of symmetry will always be x equals a number. Okay? X equals 2, x equals 5, and that's because any vertical line has the equation x equals a number. Now, the number that you'll pick will actually be the coordinate of the vertex. The vertex, just like when we looked at our absolute value function, was the min or the max. The same thing will apply. It'll be this minimum point or this maximum point. So the vertex of a parabola is the point at which the parabola intersects the axis of symmetry. And this point will always be a max or a min of the function, which is going to be useful when we get into our word problems where we'll be maximizing revenue or minimizing our cost of a function. We'll be looking at the vertex, the max or the min. Now, just to give you an idea of the parent function, remember the parent function is just your most simplest version of a quadratic. So we'll graph that here. Remember, the parent function for a linear was just y equals x. So the parent function for a quadratic is just y equals x squared. And since we don't know how to graph this yet, okay, we can create a table of values to discover what the graph would look like. And if you remember on the summer packet, there were a couple questions on the summer packet where I had said, create a table of values in order to graph them. So when you're creating a table of values, you're picking x values and you're plugging them in and getting y values and then plotting the ordered pairs as points. So I'd probably pick like -3, -2, -1, 0, 1, 2, and 3. Something like that to give me an idea of what's going on both sides of the origin. So whenever I plug this into my function, -3 squared, -3 times -3 will be a +9. -2 squared would be a +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 4, 9. Again, you should notice the symmetry occurring about the vertex. And then we'll plot those points. So -3. I did plot that one. There we go. -1, 1, 0, 0. And again, you do not want to connect these with segments. It needs to be a rounded curve. So you just are going to do your very best to kind of take and draw a rounded curve that goes through the points. You can see mine's a little bit off, but as long as it's close. Now, we will be talking a lot about the domain and range of functions, which typically was just like listing the x values and listing the y values. Now, because there are arrow tips on the edges of this, a couple of you on the pre-test had listed like 1, 2, 3, 4 as your domain, which is part of the domain. But you're going to want to represent all of the possible x values. So when you're looking at this and you're thinking about the x-axis, you're seeing the arrows and they're going ever so slightly outward, the domain is actually going to be all real numbers. If you were to continue this going on and on and on, it would always go into the negative infinity and also go to positive infinity. So when we write this domain in interval notation, we'll put a parenthesis, we'll put a negative infinity sign, which is like a sideways 8, which is the smallest value it will ever get to, negative infinity, comma, then you'll put the largest value it's ever going to get to, which will be positive infinity, and then another parenthesis. Now, parentheses are used because you're not really including infinity because that's not an actual number. It goes on forever and ever and ever. We will use a bracket instead of a parenthesis if it actually touches that number. Okay, so this was our smallest value and the largest value that it can ever be. Now, the range, and I should tell you, for quadratics, this is always going to be the same because the arrows are always going to be going out forever and ever and ever. The range is going to be, so let's just start that out, always the same. So anytime I ask you for the domain of this function, it's going to be all real numbers and negative infinity to positive infinity. The range is going to change with each question. Okay, so it'll change with each question. Depending on the graph, the range, the y values, is going to change. The range is not negative infinity to positive infinity. When I look at the y-axis, it doesn't go into negative infinity. What's the smallest y value that this graph ever touches? Caleb? Good. On the y-axis, the smallest it ever touches is 0. So because it actually touches at 0, you will use a bracket with the number 0. Because it touches that, and 0 is an actual number. Now looking up, say, what's the highest it ever gets on the y-axis? Well, it goes up forever and ever and ever, so that would be positive infinity. And with infinity, again, we use a parenthesis because it's not an actual number. It doesn't ever touch infinity because that's technically going on forever into infinity. Okay, we're going to practice a lot with domain and range this year because you'll see it a lot in pre-calculus. All right, so here's two examples too. This is a downward-facing parabola. You can see that the maximum value would be the vertex. This one is a regular-facing parabola, and that would be showing a minimum value. And here's the standard form, ax squared plus bx plus c. You'll notice that the ax squared is called the quadratic term, the bx is called the linear term, and the c is called the constant term. So below they ask us to determine whether the function is linear or quadratic, which a lot of you did get this question on the pretest. So I am only going to do a couple, and I'm going to let you guys do the rest. So before you can identify if it's linear or quadratic, you cannot just look at it, you have to simplify first. Which most of you did. You're going to need to distribute possibly, combine like terms, FOIL, etc., and see if any of your terms kind of cancel out or disappear. So for the first one, I see 2x minus 1 squared. So yesterday we talked about how you'll have to expand this to be 2x minus 1 times 2x minus 1. Okay, you're not allowed to square just the 2 and the 1. You have to expand it, and then we'll FOIL. So I will get 2x times 2x is 4x squared. 2x times negative 1 would be a minus 2x, and a plus 1. Combining our like terms, we'll get f of x equals 4x squared minus 4x plus 1. Now we can identify whether this is a quadratic or a linear function. Well, since it has an x squared, that's telling me that this is a quadratic function. Then they ask you to identify the quadratic, the linear, and the constant terms. So you're literally just going to list 4x squared is the quadratic term, comma, negative 4x is the linear term, and positive 1 is the constant term. The only reason they ask you to do that is so that you do actually simplify and not just look at the original question and identify. Okay, now the next one, we should notice we have subtraction. We also have multiplication. You do have to follow order of operations. Multiplication is done before we would add or subtract using, please excuse my dear Aunt Sally. So you are going to have to multiply these together first. And to do that, we would use FOIL again. So this x squared and this minus sign are just going to stay out front. And then I'm going to FOIL and leave everything inside of a set of parentheses. So I will get x squared minus 1x plus 1x, which will go to 0x. And then I'll get a minus 1. So you don't have to show this part, especially in an honors class. I expect you to be able to FOIL in your head. But if you want to, you're more than welcome to, but a lot of times I will skip that on the board. Okay? So we would have x squared minus 1 is what it FOILed into. You do have to distribute the negative from outside. So you don't want to just drop off parentheses. You always want to leave them there until you've made sure you've taken care of any symbols that were in front of that. So this will be x squared minus x squared plus 1. And so the x squared terms, x squared minus x squared is 0, x squared. So I should get that it is just 1. Okay. Now, technically, this is a constant function. It would form a straight line, though, right? Y equals 1 would be a horizontal line. So we can still call it a linear function. It would have no quadratic term, no linear term, but the constant term would be 1. I also would accept if you called this a constant function, too. But that wasn't one of the options in the directions. It said, is it linear or is it quadratic? And technically, it would still form a horizontal line. All right, see if you guys can try the next 3. Simplifying and identifying if it's linear. Really watches the video. All right, so below they give you the graph of f of x equals 2x squared minus 8x plus 8. We're asked to identify the vertex, the axis of symmetry, and then it says p, and it looks like there's a little like apostrophe or a little exponent. That's p prime and q prime. What these points are representing is the reflection across the line of symmetry. Okay, so anytime you see this little notation, these are both points that are reflections across the line of symmetry. So you're going to take P and reflect it across, and that'll give you P prime. You'll take point Q and you'll reflect it across the axis of symmetry, and you'll get Q prime. The vertex, you just have to look at where is the minimum or the maximum of the function. So that occurs here, which is at 2, 0. Always pay attention to the unit. Sometimes they do count by something different than ones, but you can see that they did count by, this would be 1, 2, 3, 4, 5, 6. All right, the axis of symmetry, again, remember the axis of symmetry is always going to be a vertical line. So it has to be in the form x equals. So all you have to do is look at the x-coordinate of the vertex. So the x-coordinate of the vertex is 2, so the line has to be x equals 2. Okay, it's a vertical line that goes through the vertex. And you can see they have it dashed in there. So now we're going to take and reflect the points, which they did for us. Not always will they have the point there. You might have to put it in yourself. You can see that they took point P, and they said it's 1 unit away from the line of symmetry, so I'm going to go 1 unit additionally to the other side. And then we'll write this as an ordered pair. So this would be 3, 2. And Q prime, you can see Q was up here. They went 2 spaces over and then continued 2 spaces past to get the new point, which would be 4, 8. All right, now remember, the domain is not just asking you to list the values that you see here, because it has arrows that's going on forever and ever and ever. So you're thinking on the x-axis, what's the smallest that it will ever get? Well, it's going to continue forever and ever and ever off my page. So it will be negative infinity, comma, the largest number it'll ever get to as on the domain will be positive infinity, because it's going on forever and ever and ever. Bless you. Again, if you just want to memorize that fact for quadratics, that's what it's always going to be. When we get into square root functions and stuff like that, that will change. But for this whole chapter, your domain will be negative infinity to positive infinity. If you prefer to write all real numbers, you could also write it like that. But usually we're going to use interval notation, but those represent the same thing, all real numbers. So it includes positives, negatives, decimals, all that stuff. Okay. The range is the part that you have to pay attention to. So again, when we do this, we're thinking the smallest that the y value will ever get, comma, the largest the y value will ever get. So looking on the y-axis, what's the smallest that this parabola ever touches? So the smallest y value this ever touches. Ashley? 0. Okay, again, 2 has to do with the x, not with the y. The smallest the y ever gets to is 0. So that would be bracket 0. Comma, what's the largest it ever gets on the y-axis? Well, that would be infinity. Parenthesis. Parenthesis, because we don't know what infinity is. Now, another way to represent the range, which I don't want us to do, but I like to share it with you, is that you could put that the y values are greater than or equal to 0 using an inequality. But technically, you probably have to state that it's a real number as well. So I would just stick with our interval notation that we have here. All right, let's try some down here. And you'll see that they do have the P prime and Q prime as well. So first of all, identify our vertex, which be careful. Sometimes it's hard to see where the x and the y axis are on these grids if they don't make it darker. So the vertex would be at 3, 2. The axis of symmetry then is the vertical line going through 3, so that's x equals 3. I just remember students on their quiz last year just writing 3. Make sure you have x equals 3. It has to be a vertical line. Now, P prime, I also remember on the quiz last year, some students actually telling me the coordinates of P. That's wrong. So make sure you reflect it. So we would say it's 2 units away. So let's go another 2 units away. So here's P prime. So that would be 5, 6. What do you think Q prime would be? What would the ordered pair of Q prime be? Caleb? 2, 3. Very good. Domain, again, is going to be negative infinity to positive infinity because the x values will include all positive and negative real numbers. The range is the part you have to pay attention to. What do you think the range would be for this function? Jade? Good. The lowest it ever gets on the y-axis is at 2. It does touch at 2, so I'll put a bracket 2, comma, infinity. Okay, I'm going to skip over 7. I'll have you guys do that one as a closure, but 8 is the one that's going to look a little bit different because it's a downward-facing parabola. Abby?
Because you said like the range will be different on all of them, will infinity most likely be on all of them except the...
Infinity will be on them, except that it might be negative infinity. Okay. So part of the answer, like this next one, is not going to end with infinity, but it might start with negative infinity. Good question. So that's why I want to make sure we get to this one. So this one, what would my vertex be? My vertex be? All right.
-1,
negative 1, comma 2. So then our axis of symmetry, they didn't draw it in this time, but you might want to, just for the reflection part, would be x equals negative 1. The line x equals negative 1. What would the coordinates of P prime be? P prime. Abby?
0, 2.
0, close. I think it's at 1.
Oh, the 1.
Yeah. 0, 1. And then, what would Q prime be? Jane? Negative 3, negative 2, very good. So I probably would draw that in so that you can see that's 2 spaces away, 2 spaces away. All right, domain again, all real numbers every time, negative infinity to positive infinity for these functions. Now, this is where the range gets a little bit different. Okay, remember that the range is always the smallest that the y value ever gets, comma, the largest the y value ever gets. So when you're looking at the y-axis and you say, what's the smallest it ever touches, it goes down forever and ever and ever. So you're going to start this time with negative infinity, because that's the smallest the value will ever get. Then we'll say, comma, what's the largest it ever gets to? Well, it gets to 2 on the y-axis. That would be 2, and the bracket will go at the end. So some students try to memorize that, like, the bracket always comes first, and the comma always, like, and the parenthesis comes second. It's going to be different in every single picture. You just have to look at it and say, what's the smallest, and what's the largest the y-axis ever touches with this curve. All right, why don't you guys try the closure? We'll make this into the closure number. All right, who can tell me the vertex they got? Here.
1, comma, negative 1.
1, negative 1. Axis of symmetry, Jade?
X equals 1.
X equals 1. Good. P prime. P prime. Garrett?
3, comma, 3.
3, 3. Q prime, Caleb? 0, 0, the origin. Domain is negative infinity to positive infinity. That's easy. What is our range? Ashley? Good. Negative 1, the bracket, comma, infinity. Excellent.